This is a test regarding the Minn Kota. It looks like 20 amps, though I must say the instructions are quite vague as to what it is. 2 banks of 10 amps per bank. And the Sterling waterproof battery to battery charger, which is 20 amps rated, but it will actually do about 28 amps for a short period of time. The first thing is the cables. The input cables on the Sterling are clearly a much heavier gauge than the Minn Kota. You can see the difference here, and the same with the negative. So we can clearly carry a lot more current on the cables. The Minn Kota DC cables input cables are a little bit longer. The output, we have an output of 24 volts, whereas the Minn Kota has an output of 2 times 12 volts. At the end of the day, they will both charge 24 volt batteries, and they're effectively doing the same thing. This is by isolated 2 12 volts. This is by one 24 volt. Both are fused. The Sterling unit has obviously got bigger fuses, thicker cable. But anyway, this will show up in the test whether that's of any relevance or not. The Minn Kota is what appears to be a constant voltage charger, and the Sterling is a constant current charger, which is programmable to lots of different battery types. The Minn Kota has got no program capability in this model, and as a result I suspect the charging will be quite low. Both are waterproof, or claim to be waterproof. The Sterling is IP68 rated. It's encapsulated, it's very solid. It's a brick in effect. The Minn Kota is using sealed end caps with sealed cables. I don't know what the rating is. It doesn't say in the manual, but it definitely wouldn't be IP68. But I say it's not in the manual. So now we'll do a little test to emulate use on a bass boat fishing trip. So we will run a 500 watt electric motor, or emulate a 500 watt electric motor for 15 minutes. We'll then run the boat, or emulate that for 15 minutes, and then run the motor for another 15 minutes, and then run the boat for another 15 minutes. So we will be able to see what the return ability is of the two different models in a real world situation. Up here we have a new battery bank of the standard batteries that we've been asked to test against. Here we have the ability to emulate the outboard motor. Here we have a data log system which will log the amps and the volts from each unit during the test. And here we have fully charged the battery. As you can see, we're at 0.3 amps. So this battery bank at 24 volts is fully charged, and in between each test, between the different models, we will recharge the batteries fully so we can emulate the short trip. Okay, so let's get started. Okay, we're going to do the test now of the Minn Kota. This is the set of batteries, 24 volts. What we're measuring here is the DC input to the Minn Kota and the DC output onto the units. Actually, we're not. Okay. What we're measuring is the DC input to the Minn Kota and the DC output from the battery bank to the trawler motor. Okay. This is our fake alternator. This will do 14 volts, standard, constant voltage, up to 50 amps. So this is our power supply. And this is our fake trawler motor. We have set this for 500 watts, and we're going to run it for 15 minutes. Up here we have the data acquisition system, which is ready to go. So I'll start the data acquisition system and put it onto graph. So this will now start and show us what's going on. So the first thing we're going to do now, the batteries are fully charged. We're going to switch the trawler motor on to 500 watts. So the graph is saying we are pulling about 26 sorry, 21 amps DC. So we're pulling about 21 amps with a 24 volt battery bank times 24, you're close to 500 watts. So we'll now run this here for 15 minutes, which will emulate the discharge of the battery for 15 minutes at 500 watts. Bear in mind, if you have a 1000 watt motor, that'll be different. 350 watt motor, that'll be different. We just have to pick a figure and do it for each of the tests. Okay, 15 minutes later we will stop this discharge and then effectively switch the engine on, and then we will drive for 15 minutes and see what the Minn Kota puts back into the battery. Okay. What's that thing? Okay, you see here now we've done about 8 minutes. There's the constant current of the trawler motor emulation. There's the voltage drop on the battery. And then the white line in the middle is the charge, which we haven't switched the product on obviously yet, so it's at 0. So we've still got another 6 minutes to go for the trawler motor. This is just to confirm the 21 amps, which is going into the power supply, which is emulating the trawler motor operation. Running, we have 19.9 amps going into the unit, which is consistent with two 10 amp outputs, and we're now charging at 26.53 volts output. So you can see the trawler motor switched off and the current is now going into the battery from the Minn Kota. So we'll now run this for 15 minutes to emulate the boat moving through the water for 15 minutes. Okay. Okay, we're coming up to our 15 minutes at 500 watts trawler motor. So we want to switch the trawler motor off now. So there's the motor off. You'll see the current here going up to 0. There it goes. And they're up to 0. And then we're going to switch the engine on. So our engine is now going up to 14 volts in, 23 amps. So the Minn Kota is back on again, and we're now seeing the current of the Minn Kota going up, and you can see the pink line now. We changed it to make it a bit more clear as the voltage is now starting to rise on the battery. So the Minn Kota at the minute is charging at 22 amps at 25.8 volts. So we'll leave that now for another 15 minutes and that'll be the test over. Okay, we've done our 15 minutes returning back to base. So we will switch everything off. We're doing 27.1 volts and 17.5 amps. So we'll switch the engine off now. Okay. That's that. Now we'll switch this battery charger on here and we will charge the batteries overnight to make sure tomorrow they're fully charged, and then we will do the same test using the Sterling unit. Okay. Okay, we're a little bit over here, so switching the engine off, switching the other engine on. So we overran there by about 30 seconds, mostly because I was having a cup of tea. And so we'll fire that up, we'll give that an extra minute. So we've taken a little bit more out of the batteries, but only about 40 seconds worth. The unit here is now starting to fire up. It'll take about 25 more seconds for this to fire up. Here you have a lot more battery type options that you can set for different battery chemistries, AGM, JL, etc, etc. And there's a lot more warnings by using the digital control system. So the engine's on now, so we're charging the batteries. You can see here we are now taking 27.6 amps, and the graph is indicating that there we're on the charge side. So we'll now run this for 15 minutes and we'll see what that does. Okay. Okay, we've got another, I was late starting it, so I have another 30 odd seconds to go. You can see we're still running 28 amps or 28.17. The current's being constant. You can see here the current is 28.42. The voltage has been rising slowly on the red graph there. So we'll stop this at 40 seconds, as that's how late I was last time. The unit itself is, well, a little bit starting to warm up a little bit, but nothing going on there. So we will now stop the engine and start the trawler motor. So here we are back on. I'll just check this again, put this to 0, and I'm on 21 amps here. Put the trawler motor up to 500 watts. Alright, we changed the batteries on this unit. And you see we're back to 21 amps here, but this doesn't affect the data acquisition system. It's running from shunts anyway. So we're under 40 seconds over. We're going to switch that off and switch the engine on. So the engine's on. The Sterling battery to battery charger, we have a slow ramp up, so you don't hit the alternator on the engine with a fast instant on thing, which could cause your belts to slip, etc., etc. So that's the reason why we have this not sort of starting instantly, but we actually ramp up the current so as not to jerk the alternator. It only takes about 20 seconds and it should be working. There we go. We're up now to 27.6. Confirmed up here, 27.13. Nearly up to 28. And we'll now leave this for another 15 minutes as we charge the battery again. Okay. Alright, we're nearly at the 40 seconds, so we'll switch the engine off. We're still doing 29 amps here, and you can see up here 29.16. So switch the engine off. So that's the end of the test. It's, I don't know if it's a typical test or what, but it's 15 minutes, 15 minutes, 15 minutes, 15 minutes. So we'll now take the information from the data acquisition system and we'll put the two graphs together so you can see the difference between the two products, and we'll show you that in a few minutes. Okay. Okay, you can see here the batteries are full. We're down to 0.01 amps, so these are done. Switch the charger off. So this battery bank's full. We're now going to test the BBW1224. That's 12 to 24 volt unit to charge those batteries. This is again our fake outboard motor, our fake trawler motor, and our data acquisition system. So let's fire up the data acquisition. Go onto the graphs. Okay, that'll scan every 5 to 10 seconds. We will wait till it does the first unit. Then we will, there it goes now. We will switch the outboard on and start the timer. So everything's working here. You should see the current there. We are pulling, should be 21 amps. I just checked that to confirm it. We're at 20 amps. As it warms up, it'll take a little bit more, it'll warm up. Okay, so we'll leave that now for 15 minutes and see how that goes. Okay, as we can see here, the charger has fully charged these batteries overnight, so we're ready for the next test. So the first thing is we'll switch this charger off. So that's that off. Batteries are full. We're going to test the BBW1224. Again, we have the fake outboard motor. We have the fake trawler motor, and we've got the data acquisition system. So the first thing we'll do is switch on the data acquisition system. Click graph. Then we will simply switch on the outboard motor. Should be doing about 21 amps, which is 20.94, which is close enough to 21. And we'll now start the clock. And we'll run this now for 15 minutes. We'll go back in 15 minutes and see how we're getting on. Okay, what we're going to do now is simply charge these batteries back up. We've been taking 500 watts out on the trawler motor, and we've only been returning about 300 watts, so there's still a net loss in these batteries. So we're going to use our constant current charger here. This is the new Sterling charger. It's not waterproof, so it's not suitable for this job, but we're just going to simply charge these up overnight to make sure they're fully charged, ready for the Sterling test in the morning. And as you can see, we're at 27.6 volts on this, and we're still putting 30 amps in at 24 volts. So we will fill these batteries up, and then we're ready for the test first thing in the morning. Right, what we've got here is the actual graph of the Minn Kota test. The green is the trawler motor, so the area of the graph, under the graph, is the actual energy or the power you've taken out of the battery. You'll notice we've done 42 amps here, when in actual fact, if you look at the test, it was 21 amps, but that was 21 amps at 24 volts. So we've doubled that up so that at 12 volts you would have used 42 amps, and this gives you the correct size of the area of the energy you have actually taken out of the battery. Up here is the charge curve of and the area under here is the energy you've put back into the battery. So you can see you've taken out well over 2.5 times as much energy as you've put back in again. This small graph here is the rise of the voltage of the battery as you have charged the battery up. Now that is the Minn Kota one. Let's have a look at the Sterling one. So straight away you see the obvious more power there, but it's exactly the same amount of power taken out for the trawler motor test. But the difference here is quite dramatic, where you can see we are more square because our charger is a constant current charger. So we'll put the two together and see what they look like. This is scaled. So as you can see, we've both taken the same amount of energy out of the battery, but look at the amount of difference that the Sterling has put back in again, mostly because it's a constant current charger and not a constant voltage. The end result is that we have put in about 60% plus extra energy than the Minn Kota has put in, and that's really all we can say about it. Okay.